Hello champion, welcome to my math class. I'm teacher Adam, and on our previous math class we had discussed on distance time graph. Today we're going to learn the same unit, but we're going to a sub-unit of speed time graph. We know distance and time are related together. Distance divided by time, you get speed. And from the we were able to, in our previous math class, we were able to analyze and we were able to interpret distance time graph. Like for maybe somebody, let's say teacher Adam is moving from his house going to a specific town, maybe going to Msasani. Then Mr. Adam will rest there in Msasani without moving, maybe talking to his friends for about an hour, and then later on he will go to visit his friend who is in Masaki. Maybe distance from Msasani to Masaki is about, let's say, 5 kilometers. Then you're told to plot the distance that Mr. Adam traveled, and maybe you're told to find the total, maybe the average speed that Mr. Adam used throughout the journey. So, and some kind of interpretation, maybe a place where Mr. Adam was resting, maybe what was the speed, those kind of understanding. These are the concepts that we learned in distance time graph. But right now we are also going to look on speed. The same knowledge of distance time graph we are going to apply here because it's not different. I'll start by introducing what speed is. So here we can say this is a distance time graph for a cyclist. So we have here distance time graph here given. It's an example. So we have been given distance in meters, which is 0. You can see on the y-axis we have distance in meters. So 0, 20, 40, 60, 80. So we have there, like you can see here, 0, 20, 40, 60, 80. The graph is a straight line. This shows that she's moving at a constant speed. And actually we reviewed, when you see a straight line in a distance time graph, that means the speed is constant throughout the journey. But whenever you see you're given a graph, let's say a graph like that one, and then in between there's that, then there's that. Obviously there will be change. You never know. They cannot have the same speed. And probably whenever you say, okay, whenever you have a straight line, what about if we have a curve? Let's say you have this, and then you have this, and then something like this. We said when you have a curve, there's no way this point will have the same speed. Yeah, the point here and maybe a point here and a point here. There's something that is changing. What if you have another graph like that one, and then the car goes this way? So you cannot say these points have the same speed. Yeah, but whenever you have a straight line like this one, it shows that the speed is constant throughout the journey. So if Mr. Adam was moving from Msasani to Masaki, maybe at a pace of 20 kilometers per hour, the speed will not change. It will just remain 20 kilometers per hour. So the same understanding. Let's review on what speed is. So we automatically understand that speed is equal to distance divided by time. Yeah, so that's what we understand. Speed is equal to distance divided by time. So if you're finding the speed here, we'll obviously take distance, one of the distance, let's say 80 meters. It was covered in 20 minutes. So we know for sure speed can be in terms of miles per hour, or meters per second, or kilometer per hour. So these ones, either meters per second, kilometer per hour. Yeah, that's the way you represent speed. And when you're told to analyze or solve a question, should not be an issue because we understand how distance and time together with speed are connected. Correct. So the distance she travels in 20 seconds. So if you're told to find the distance she's traveling in 20 seconds, remember we say when we have speed, speed is d over t. So when you're looking for distance, we say distance is equal to speed times time. So you obviously take your speed, what you got in terms of speed, and then divide by you take speed times time, not when you are told to find the distance. So the distance she traveled in 20 seconds. In 20 seconds, they say the distance is, so you take the speed times the speed, which is 4 meters, times the time, you get 80 meters. Correct. Okay, say the horizontal line shows that she is moving at a constant speed. So we know that we have said when you have a horizontal line. A horizontal line shows she is moving at a constant speed. We understand when you have a horizontal line like this one here, you see, like this shows that this object is not changing in speed. There is no change in speed. So if it's 4 meters, it's 4 meters per second throughout the journey. The area between the line and the x-axis gives the distance traveled. So whenever you are told to find the distance traveled in a speed time graph, the area between the line and the x-axis gives the distance traveled. So understand, by finding the area, you'll be able to find the distance covered by an object in motion. Correct. So why do we say that? Because this is speed and this one is time. The y-axis is speed and the x-axis is time. Therefore, when we have speed and time, we need distance. We know distance is speed times time. That's why we take our speed, there are 4 meters per second, times the time taken to cover is 20 seconds. Then you get 80 meters. This is the total distance covered by an object that moves in 4 meters per second for 20 seconds. That's it. So here we've been given an example in which you have now the speed is changing. So you can see speed is changing. It's moving from 4 meters per second to 7 meters per second. And then we can look at the change in speed. So we have our initial speed, which is 4 meters per second. This is initial speed. And then we have our final speed, which is at 7 meters per second. We have these two speeds. We have 4 meters per second and 7 meters per second. And then maybe they want us to find the change in speed. What is change in speed? We can as well look on time taken for the change of speed. So you can say, remember, it was at 0 and then it took 20 seconds for the change in speed. Now, what is change in speed? For example, here you can see the speed is increasing from 4, it goes to 5, then it goes to 6, then to 7. But here the time was 0. At 0, the speed was 4 meters per second. At 20 seconds, the speed is, there's a shift there. And there is movement here. So at 20 seconds, and a shift of 7 minus 4, which is 3. So there is change in speed in a given time. What's change in speed in a given time called in mathematics? That is also very important in your Igcse final exam. So you say, in this case, the speed increases uniformly from 4 meters per second to 7 meters per second in 20 seconds. The rate of increase of speed is the acceleration. So the rate of increase of speed is acceleration. So we have a new term that is being used in Igcse math, both Igcse math and physics. Igcse physics, acceleration. This topic is related in both units. So if you know the mathematics one, you can apply the knowledge in. If you know the mathematics one, you can apply the knowledge in the Igcse one. So we say the rate of increase of speed is the acceleration, the rate at which speed change per given time. You can as well say that. So you can say acceleration 7 final speed minus initial speed divided by the time taken. And you get your formula as the answer as 0.15 meters per squared time. As before, the area between the line and the x-axis give the distance traveled, area of a rectangle and area of a triangle. So, and then you say you have 20 times 4 and then plus a half times 20 times 3, 110 meters traveled. So I'll show you how they got it. So remember, we have two objects. We have A and B. It looks like a trapezium. Look at this shape. So that you have figure A, which is we are trying to separate it. We have figure A, which is a rectangle, and figure B, which is a triangle. So this is triangle. You can see. So we have figure A and figure A is this one, and that's figure B. The distance covered is the area between this line. So it's the whole of this figure. So that's why they say area of A plus area of B will equal to distance traveled by an object. That's it. So you find area of B, which is our figure B. We call it a half base times height. That's area A. And area of B is length times width. That's it. Whereby you take a half times, the base is 20, times the height is 3. What do you get? You get 30. But this one, you will take 4 times 20 and you get 80. So the two, when you add the two, you just take 30 plus 80 and get 110. And that's, you'll find the total distance in meters, 110 meters. Both of them are in meters. Second cancelled. Correct. Now we know that the rate of increase of speed is the acceleration, the rate at which speed change per given time. That's the definition. You get acceleration, and the units is always meters per squared time. That's m per second square. This is for acceleration. Don't forget that. Example 4, we go to an example here given. So we say this is a speed time graph for a car over 15 seconds. Describe the car journey. So we have been given here an example. So we need to describe the car journey. So you can see the car is changing speed from this point to this point. How long is it? It's like from 0 second to 5 seconds. The car is changing speed. So let's say this is point A, point B. Point A and point B, we have constant speed. We have constant speed of 50 meters per squared, 50 meters per second. And then you can see the speed is reducing from point B, and let's say I'm calling it this point as C. So it's also reducing. And we know the area below this, the line, below this line is the total distance covered by an object. So describe the car's journey. A graph for a car over 15 seconds. So you can see all this one is over 15 seconds. So we can see here the car is accelerating from this point to point A. Then it has a constant motion or constant speed, and then later on it reduces its speed to point C. Now we say in the first 5 seconds the car accelerates steadily from 30 meters to 50 meters. And the acceleration, now we go to our example so that we all move and we describe better so that we are all at the same page. We can see our initial speed was, because this is a speed time graph, on y-axis we have speed, on the x-axis we have time in seconds. Now we know at this point here we have our initial speed is 30 meters per second, and then from this point you can see from this point to point A here, the car is increasing in speed. The car is increasing in speed. So under specific time to 5 seconds. So we say time taken, and we say final speed. The final speed here is 50 meters per second. But time taken is 5 seconds. And we know change in speed, the rate at which speed change per given time is called acceleration. Therefore, acceleration is equal to final speed, which is 50 meters per second minus 30 meters per second divided by the time taken. So that will be 20 meters per second divided by 5 seconds. What do you get? In this case, you get 4 meters per squared second. Wow, this is what we get, acceleration. For the next 6 seconds, the car travels at a constant speed of 50 meters. We have seen, if you go to the graph, you'll see that we said a horizontal line shows constant speed or constant motion. The object is not accelerating. Then the next thing we say, for the last 4 seconds, the car slows down steadily from 50 meters to 20 meters. Because the speed is decreasing, you can say the car is decelerating. So the deceleration, you take the initial speed minus the final speed divided by the time taken. The same we're doing for acceleration formula. So here it's quite different. Just say we go back to the graph so that you understand. So here it was at 50 meters per second. Look at the time. It was at 11. 11 seconds. It was at 11 seconds from this point, and then it went up to point C, whereby it's 15. So time taken is 15. 15 minus 11, we get 4 seconds time taken. And then for the car to reduce its speed, and then change in speed is 50 minus this one, which is 20. You can see here it's 20. So 50 take away 20. So that's what you do. Acceleration, 50 take away 20, divide by 4. 30 divided by 4. Correct. Then you get your answer as 7.5 meters per squared second. And then say the area under the line gives the distance traveled. We know for sure you can make if you go there, if you want to find the distance, look at this shape. Let me erase everything so that we are all on the same page. If you look on this page, let me make this so that you may understand. Look at this page. If you split here, and you will have this figure 1, which looks like trapezium, the whole of it. And look at this, the same to here. The same to here. You also have a trapezium here. In that case, you have a trapezium here and here. So you have A and B, which are trapezium, and then you have rectangle at C. So if you find the areas of this, if you find the area of A, B, and C, you add them together, you get the distance covered by this object. Thank you. So you can see here, the area under the line gives the distance traveled, and actually we say we can have two trapezium and rectangle, then you add them together, you find the answer as simple as it is. Let's go to the question. Now we're going to, this is an exercise. They say the speed time graph shows a car accelerating for 40 seconds. What is acceleration? Is say the rate at which speed change per given time. That's acceleration. And then you say the speed time graph shows a car accelerating for 40 seconds and then decelerating. Okay, it's accelerating and then decelerating. You can see, yeah, it's accelerating for 40 seconds and then decelerating. And then what's the maximum speed of the car? The maximum speed is when it reached here, 20 meters per second. That's the maximum speed. Yeah, you don't have even to calculate, because here this one is a speed time graph. It's not like a distance time graph. They say the maximum speed will be the maximum point on the curve. So this is the maximum speed, 20 meters per second. That's maximum speed. So here they say, what's the maximum speed? You write 20 meters per second. You get your mark. You get that. What is the initial acceleration? What is acceleration? We know acceleration is the rate at which speed changes per given time. Let's go to the curve. What's the initial acceleration? The initial acceleration is 0. Because it's at 0, then it went up to 20. The speed here is 0. So, and then the final speed is 20. So the initial acceleration, if you are looking for acceleration, it will be 20 minus 0 divided by 40. So which is 20 over 40, which is 0.5 meters per squared. That's the initial acceleration. So if you're looking for initial acceleration, you take the final speed minus the initial speed divided by the time taken, which is this one. You're looking for the initial acceleration, you have to know the rate at which, and we know acceleration is equal to the rate at which speed changes per given time. So the time that the speed changes is 40 seconds, and the speed came from 0 to 20. That's it. So you just say 20 divided by 40, you get 0.5 meters per squared seconds. Okay. What is the deceleration for the second part of the journey? Deceleration is the rate at which speed changes per given time, and speed reduces per given time. So the speed reduces from 20 to 0. So you say here, you can see it's reducing from 20 to 0 under what given time? So you can see here, you have 20 minus 0 divided by, that's the initial speed minus the final speed, and then divide by the time taken, 60 minus 40, 60 minus 40. This is deceleration. So what do you get? You get 20, 60 minus 40, it is 20 also. You get 1 meters per squared second. That's it also, you get that. Then the next, what's the distance traveled? The distance traveled will be equal to the area under the curve. Our area under the curve, so area is a half base times height. 40 seconds times height, which is 20 meters per second. That's it. 400 meters. And then find the area of the other one, which is area of A and area of B. The same, so area of B is also a triangle, a half times base, which is 20 second times the height, the speed, which is 20 meters per second. Then you also get total distance, 400 plus 200, you get 600 meters. Correct. You get that total distance covered. These are very simple questions. Yeah, and then say, what's the average speed for the whole journey? Average speed for the whole journey is total distance covered divided by total time taken. Total distance covered, which is 600 meters, divided by the total time taken, which is 60 seconds. You get 10 meters per second. That's the answer. Let's try question number 2. Question number 2, the speed time graph shows a train slowing down as it approaches station. What is the deceleration of the train? Deceleration, we means, is the rate at which speed changes, especially the decrease, the rate at which the speed decreases per given time. That's the deceleration. Speed decreases per given time. So you can see the speed is decreasing from 30 meters per second to 0 under 50 seconds. So we know now deceleration, we will take 30 minus 0 divided by the time taken, which is 50 seconds. So you have 30 out of 50 meters per squared second. That's 3 out of 5 meters per squared second. What is the distance traveled? The distance traveled is equal to the area under the curve. The distance traveled is equal to the area under the curve. The area, this one, is a triangle. Just say area is a half times base, which is 50 seconds times the height, which is 30 meters per second. This the high speed. To here 15. Then you multiply, you get 750 meters. This is the distance traveled by this object. Wow, by station, we can say by a train. So the train traveled or covered 750 meters. So let's look for the last example, number 3. You can see we have different kind of question. Look at question number 3 as you scroll down. Look at question number 3. So question number 3 here, you can see we've been given the speed time graph, show the speed of a boat over 30 seconds. What is the acceleration for the last 10 seconds? What is the deceleration for the first 10 seconds? What's the distance traveled? What's the average speed? So what we basically need to understand is what is deceleration, what is acceleration, what's constant motion. If you know that, you'll be able to solve this kind of questions in your final Igcse exam. See you at the top champion. Bye bye until we meet again in the next class.